Today we're going to make an Arduino office door sign that displays custom messages when you're not there. Maybe you have an employer or coworkers that want to know where you are during the workday. Well, this will leave a message on your door letting them know how to best get a hold of you or what you're doing. And you may have seen these on Amazon. I've seen these on the doors in the building that I work in, and my first impression was, they're kind of boring. I think I can do better. So let's go ahead and build one with Arduino and make it a little more unique and custom and see what we come up with. Let's go ahead and get started. Today we'll be using the Arduino Uno R3, the HC-SR501 PIR motion sensor, an I2C 20x4 LCD module, a breadboard power supply, 100 microfarad capacitor, some breadboard jumper wires, a breadboard, and a couple of momentary buttons. Some of you may be using the standard LCD display, and it's perfectly fine. You can use that in this project. But I've switched to an I2C display for a number of reasons. One, it's easier to use and it requires a fewer number of pins for your microcontroller. And also each I2C device has a unique address. And you'll notice that most of the LCDs will have an address of 0x27, but yours may be different, so make sure you know which one before you start your code. And the I2C devices use two data lines, the SDA, which is serial data, and the SEL, serial clock. And these lines are shared among all the I2C devices on the same bus, and that allows you to use multiple devices to communicate using just two wires. Here's a look at the setup I have. I have these two buttons. They're connected to pins 3 and 10, and that's just arbitrary. I have a 100 microfarad capacitor on the breadboard. Now ideally the capacitor should be connected as close as possible to the power pins of the LCD. Here I have my motion sensor, and the signal pin is connected to pin 2 of the Arduino, and then I have the power pins connected to the breadboard as well. And here is a view from above what the project looks like. Here's a diagram. I also should add that I used a 9-volt 1 amp supply on the breadboard power supply, and I used just a USB in the Arduino. Here's a little demo, and I push a button here and it'll cycle through the different messages that I can type in, and then this button will cycle in reverse. So we'll go ahead and set one, and we'll take a look from above here, and once motion is detected, the message is left and then it goes off. And I guess somewhere along the way the ground pin of the LCD got switched to the other power rail on the breadboard. You want to keep those as close to the capacitor as possible. It's not as important here, but if you were to power this by battery, you might want to make sure it's as close as possible to those power pins for the LCD. And it's just a demo of what I got. And you can add your own messages. In fact, I'm going to add a few messages that are more specific to me and where I work, and you'll see those in the code coming up here. Here's our sketch, and since it's commented extensively, I'll just go ahead and give you a brief overview of what's going on here. And this top section, this is a global section, and this is where we define libraries, constants, variables, and objects used throughout the rest of the program. In this section, we include the Liquid Crystal I2C library for functionality and control of our LCD module. In this section, the LCD object is initialized with the I2C address and the dimensions of your LCD module. We also include constants that define which pins are used in the PWM control, the motion sensor, and the buttons. We also include a message array that stores a list of messages that can be displayed on the LCD. And we include global variables which track the current message index, the button states, and timing for the backlight control. Then we have our setup section, and the purpose of this section is to initialize hardware settings required for the program to function correctly. So you'll see here we set up the pins as inputs and outputs and enable internal pull-up resistors for the buttons. This begins serial communication for debugging purposes, and here the LCD is initialized and cleared. And here we include backlight control, which ensures that the backlight is turned off when the program starts. And in the loop section, the sketch continuously monitors the state of the buttons and motion sensor, and it updates the display and backlight. This is our button handling section, and it checks to see if the forward or backward button is pressed to cycle through the messages, and then the selected message is displayed on the LCD. This is our backlight timeout. If no buttons are pressed for 2 seconds, then the backlight is turned off to save power. This is our motion detection section. If motion is detected, then the message will be displayed for 10 seconds in our LCD module. And at line 133, this turns on the backlight by setting the PWM pin to full brightness with a value of 255, and this turns off the backlight by setting the PWM pin to 0 and clearing the LCD. Thank you for watching. If this video was helpful to you, be sure to like the video by clicking the thumbs up. Also consider subscribing and share it with somebody else who may find benefit from it. And I will see you again very soon with another video.